Okay, here we're going to talk about indeterminate form. Indeterminate form is when we're finding limits and we either get for a result 0 over 0 or infinity over infinity, which means that we cannot determine a limit at this point. So I want to go through and look at ways to solve these type of problems. So the first thing that we've learned when we're doing these, and I just want to look at this. This is limit as x approaches infinity. If you plugged 2 in right here, you would get 2 squared, which is 4, minus 2. I'm just going to write it out. Okay, so we will get 2 squared, which is 4, minus 2 and minus 2, which will ultimately give us 0 over 0. This is indeterminate form. And it's basically telling us what? We cannot determine the limit at this point. So the first way we learned to solve this was by factoring out the numerator. All right. So we're going to factor out the numerator. So that's going to be x minus 2 times x plus 1 over x minus 2. Okay, so we factor that out. And then we cancel it out. We can cancel out our x minus 2's. And what are we left with? We're left with a simplified version of this. The limit of x plus 1 as x approaches 2. We simply plug our 2 in. 2 plus 1 gives us 3. That was the first way that we learned how to solve a problem that ended up in indeterminate form. Now, we want to use another term. This is called L'Hopital's rule. Or for the misspelling, L'Hopital's rule. Here, you can see we have the same problem. If we plug this in, and I'm going to put it right here, we will get 0 over 0. Remember, this is the exact same problem that we looked at before. But in this case, what we want to do, we want to find the derivative until this problem worked itself out, all right? So the derivative of x squared minus 2x, x squared minus x minus 2, the derivative of this is going to be 2x minus 1, and the derivative of x minus 2 is just 1. Now we want to try to plug in our 2. And if we plug the 2 into this equation, we will get 2 times 2, which is 4. 4 minus 1 gives us 3 over 1. And as we know, 3 divided by 1 gives us a 3. So we can see we still have the same answer, whichever way we tried the problem. Now, I want to look at the problem down below. In this case, our limit is going towards infinity. So as we know, if we were to substitute and put infinity in for x, we'll get 3 times infinity squared minus 2 times infinity plus 1. Of course, we all know that would result in infinity in the numerator. All right. And if we plugged in infinity in our denominator, we would also get infinity. So once again, this is indeterminate form. okay? So in this case, we go back down to the bottom step. And we find the derivative of the numerator and the denominator. And we are going to find the derivative until it works itself out. Okay, so the derivative of the numerator here, 3x squared minus 2x plus 1, is going to give us 6x minus 2. The derivative of the denominator is going to be 4x. But now what happens? If we plugged in infinity, once again, we would get what? Infinity over infinity. That's no problem. Let me draw this here. That's no problem. That's the beauty of L'Hopital's rule. We just do it again. And we basically are able to do it until it works itself out. So let's go down to the next step. We'll repeat this again. And the derivative of 6x, let me plug this in. The derivative of 6x minus 2 is 6. And the derivative of 4x is 4. Right? So 6 over 4. Our answer here would be 6 over 4, which reduces down to 3/2. So that's what give us our final answer. All right, so we can look on the left. That's the way we learned how to do the problem when we first started learning about limits. And on the right, same problem as the top one, but on the right, we can see how we solve the problem when we're using L'Hopital's rule.